Greetings, friends. As always, it's an extremely high honor to welcome you back to Rick's Garage. What you see before you is the electric motor that goes to my Amco brake lathe. If you're familiar with my channel, you've seen me using this machine on a number of my videos. I purchased it used about 6 years ago. I think I paid somewhere around $800, maybe it was $850 for it. But it's been a great buy. I've been using all these years. Every time I use it, I probably save $100 or more to either myself or a family member. I only work on friends and family vehicles these days. So it's been a lot of fun having it, but just recently the motor started screeching. It was obvious that one or both of the bearings were bad. So I wanted to replace it. I want to continue using this machine. So I looked up the price of a new motor for this machine, and it was over $700, just about what I paid for the machine in the first place. So that was kind of out. I really didn't want to spend that much money on this thing. So I decided to try to replace the bearings myself. So friends, I apologize for this, but I did not cover the replacing of these bearings. The job is done. It came out great. The motor's nice and quiet now. I've tested it, and I'm getting ready to put it back in my machine. The reason I did not cover this repair is I am not an electrician. I didn't feel as though I was qualified to walk you through working on something so dangerous, and yes, it is dangerous. Furthermore, I am colorblind, so working on electricity and being colorblind is not a good combination. But what I do want to do, if you're familiar with my videos, I'm always talking about safety. So I just want to cover some of the things I've learned about working safely with these motors. There's many different electric motors. I watched maybe 8 or 9 videos before I attempted this one, and this one wasn't really like any of the ones that I saw on YouTube. Made a couple of mistakes. I somehow disturbed the points, the contact points that activate the capacitor. This has a startup capacitor. If you've ever worked on one of these motors that has these little covers on the side, inside there is a capacitor. So I disturbed the points that activate the capacitor, and when I originally tried out the motor after putting it together, the motor would just sit there and hum. It wouldn't actually start. So I had to take it apart again and find out what I did wrong. I adjusted the contact points so they were actually making contact, and then I was able to put it back together and got it working correctly. So friends, as I just said, I did not feel comfortable walking you through this repair because I'm not an electrician. The purpose of this video is I want to share some of the things I learned as far as safety. If you're familiar with my channel, I like to have a safety moment from time to time. So these are some of the things you're going to need to safely work on this motor if you choose to do so. First and foremost, you want a pair of electrician gloves. You want gloves that are rated for at least 400 volts, as are these. You want safety glasses. You want tools that are insulated. You want a multimeter. At certain intervals on working on these motors, as you watch the videos on YouTube, they may show you how to test certain things using a multimeter. What I used the multimeter for was testing microfarads of the capacitor, and I also used it to test continuity of the points that I told you I had messed up. And lastly, you want one of these little devices. You can buy them at any hardware store. They're very inexpensive, and they test for voltage. They don't tell you how much voltage, they just let you know whether voltage is present or not. I'll show you how this works. But I'm going to go over to something that I know is plugged in. You can see how it beeps and it blinks. That's telling you there's live voltage there. So that's handy to have. Friends, I want to talk to you about the capacitor. If you have one of these covers on your motor, that means you have probably a startup capacitor. These capacitors can hold a dangerous amount of voltage for a number of days. So even though the thing is unplugged, there still could be voltage in this capacitor. So what I've done is I've put my high voltage gloves on. and I'm using a insulated screwdriver, and also I have my safety glasses on. I'm going to open this up and show you what's inside there. A couple of screws usually hold this cover on. And the reason I'm taking this off is something that was not covered on any of the videos I saw, and I wanted to mention because I think it's very important. Okay, here's your capacitor. Now usually it's flopping loose inside that cover. And what I wanted to point out too, if you look inside the cover, I don't know how well you can see it, but there's a little insulated pad here. There's no pad on the other side. So when you install this cover, you want to put the insulated pad so it's on the same side as the wires that attach to the capacitor. You don't want the capacitor flopping around and coming in contact with the metal surface, and thus electrifying the outside of this thing. So when you install this, look for that insulated pad, and always put the insulated pad as the same side as your wires. Now I'm going to go ahead and disconnect the capacitor. I don't know if there's any voltage on it or not right now. It's been off for a number of days. Here you can see, look at, even though this is unplugged, there's voltage coming from that capacitor. So don't be fooled just because you have something unplugged. You don't think there's any voltage there. So I'm going to carefully unplug this thing, and I'll show you how to discharge it. Okay, I'm focused in on this a little bit. I've got my high voltage gloves on, and I've got an insulated pair of pliers. I'm going to carefully unplug this thing. One plug is off. The other plug is off. Alright, so I'm going to go ahead and discharge this capacitor. So you may see a little spark. What you want to do is you want to just take your screwdriver and just make contact with both things. Now this should be well discharged, but I'm not going to stick my fingers on it to find out. Okay, so I'm going to go ahead and carefully put this back together again. I'm going to plug in, doesn't matter which wire goes to which. Plug that in. Oops, I missed that. Yeah, that one's plugged in. Okay, I'm going to put this cover back on now that I've connected up the wires. And I'm going to make sure that the insulated pad is on the same side where the wires are in case this thing flops around. You don't want it coming in contact with this metal thing. So let's put that on. And I'll tighten this screw a little bit. There we go. Now we'll get the other screw started. Now I learned a little trick over the years. Take a high-powered magnet, put it on your screwdriver, and that'll help hold your screw in place while you're trying to get it started. See, my screw and my washer now are in place, and I can get it started very easily. There we go. Alright, so my cover is on my capacitor. The capacitor has been discharged, and my pad, my insulating pad, is on the same side as the wires. Now the other thing I just want to mention briefly is I had a little trouble trying to figure out what bearings this motor took. And what I found out was when you take it apart and you take the old bearings off, every bearing has a number stamped on it. So I was able to find the number stamped on the bearing, and it's on this particular motor, it's bearing 6203Z. So I simply went on eBay and ordered a couple of bearings with that number, and they fit perfectly. And so now this motor is ready to be reinstalled in the machine. Now I just want to point out that what I did was I cleaned part of the motor cover, and I put the bearing number on the outside of the motor, so next time I need to order bearings, hopefully I won't ever have to again, but if I do, I'll know what bearings to order before I take the motor apart. Now, just one other thing I want to cover if you are actually working on one of these Amco lathes. What you need to do to get the motor out of the machine is you have to tip it up. Let's see if I can do this by myself. I'm an old man here. So you have to tip the motor up to access this plate to install the motor. And what happened, the mistake that I made is after I got the motor out, I left the machine tipped up like this overnight. I'm going to set it back down because I'm not quite ready to try to install that motor. But what had happened, and I'll move the camera, leaving that thing tipped up overnight, you can see the big stain on my floor. When I got up the next morning, I had a big puddle of gear oil all over the floor in the shop. So I learned my lesson with that. You can tip it up and you might get a drop or two, but not much. If you let it sit over a day or two, you're going to get a big puddle of oil on the floor that you have to clean up. So I just wanted to point that out. If you are going to work on one of these machines, don't leave it tipped up for too long. So I'm going to put this motor back in probably tomorrow, and I can start using my lathe again. So that's all I've got, friends. I want to thank you once again for watching Rick's Garage. Again, I apologize for not showing the replacement of the bearings on this motor, but like I said earlier, I'm really not qualified to show you that. I just kind of learned it myself by watching some YouTube videos. I am not an electrician. I just want to pass along a few safety things that I learned in the process of doing this job. So before I go, I am going to post 2 videos to your left, of which I hope you find of interest, probably something to do with using my brake lathe. And to your right, as always, we have a picture of my avatar in the form of my very trusty German Shepherd. By all means, feel free to click on that, should you wish to subscribe to my channel. So thanks again for watching. We hope to see you all very, very soon.